Hey everyone, welcome to today's webinar and thank you very much for joining in wherever you're joining from. My name's James. I'm a product manager here at causaLens. Thank you again for joining. I'm joined here with Adam.
Hey guys, I'm Adam. I'm a senior applied data scientist at causaLens.
And also by Darko.
Hi guys, Darko, co-founder and CEO. Super excited to show you how we can use software to manufacture labor.
Yeah.
In our case, we're manufacturing something that previously was thought impossible, creating an agent that can do data science, creating an AI data scientist. So what we will show you today is a fun example. Given that we're a British company, we chose football. And we'll show you how we're going to do something relatively complex in terms of optimizing how we allocate football tickets to different merchandisers in order to kind of maximize sales. But this is just a fun example. In the real world, we do all sorts of cool things from manufacturing to retail and everything in between, really complex use cases, different parts of the data science process. For the first time, it's now possible to create agents that automate this knowledge work. And that's what we're going to focus on today. Let me just give you kind of a high-level overview of what you will see. We will show you how we create how do we manufacture human labor specifically for data science. And then we'll show you how, if you're an executive or any business person, you'll be able to use and interact with this AI agent from wherever you want, from your Slack, from your email, from your WhatsApp. And when you interact with them, this AI agent is going to do quite complex knowledge work actually for you in the background. One of our customers, we have the CFO, always wanted to ask questions at midnight. And the data science team, would always be very anxious waking up because they get the CFO asking some really complex questions, and that would take them a few days, a few weeks to answer them. Well, now this CFO has an agent. They can ask, at midnight, a complex question, and they'll get the answer straight away while the data scientists are sleeping peacefully. And so that's really what we're going to show you today. So over to you, Adam. I'm going to step out. I'll be back for the Q&A, leaving you here in capable hands. Enjoy.
Thank you, Darko.
Wonderful. Thank you very much, Darko. So as Darko mentioned today, what we're going to be doing is we're going to be building a data science agent in 30 minutes. Sometimes we call them AI data scientists. So that's what we're going to be building. We're going to build the agent. We're going to evaluate the agent, ensure it's performing well. We're going to publish the agent for your whole business to use and see. And then again, we're going to use the agent, and then we're going to finish up with some Q&A from the audience. Wonderful. So jumping into the use case that Darko mentioned, we're going to be building the ticket allocator agent. What we found is that through a customer engagement that we have is that optimizing inventory allocation is a really, really common challenge across industries. And what we mean by optimizing allocation is, that could be inventory of a certain good, that could be a volume of something. And you really want to optimize these things and prioritize a certain metric, whether that's profit or revenue or another metric of your choice. And what happened and what we found in this customer engagement is that it's often handled by teams of data scientists and analysts, and then collaborating with the business team that is concerned with the allocation. So what we found in this customer engagement is that the business teams would ask for the allocation to be readjusted. So in this case, football tickets, they would ask for this to be readjusted. They would communicate that to the analysts, which could take time. And then the analysts would communicate this and request that the optimization algorithm is changed by the data scientists. And then what would happen is that the data scientists would communicate those results back to the analysts and then back to the business teams. And so this is obviously a process that took a really, really long amount of time. And what we want to show you today is how the ticket allocator agent can do that for you instantaneously. So as Darko mentioned, the ticket allocator agent allocates the most precious resource in this country, football tickets, and it allocates it across different amounts of vendors or merchants based on their previous sales history, but then also based on their potential revenue that they can make from that. And so although it's a different use case, it under the hood is really, really similar. So it ingests historical data, it adjusts constraints of an optimization algorithm, and then it allocates these tickets to maximize the revenue. And again, as I mentioned, what's the value of this? Well, the value is you've taken a process that took 3 teams and weeks to complete down to a process of just a single agent. And as Darko said, the CFO asking a question and getting an answer in seconds. And so the really big value here is that it frees teams to focus on these higher value tasks. But really what another benefit of it is that it makes these allocation tasks viable at far greater frequency and far greater granularity. And really what that means is that, you've taken it from weeks to seconds, which means that, okay, it used to take 3 teams and I could only do it once a month across the whole of the United Kingdom. Well, now if this process takes seconds and it's done by an agent, this can be done at far greater frequency and far greater granularity. So if you want to do it every day, you can do this allocation process. If you could only do it on the UK level, now you can do it at the city level, or maybe at different, vendors in different boroughs. So there's a lot of opportunity that this brings to the ticket allocation agent brings to a business when compared to having data scientists, analysts, and business teams run, chase each other around to get this process done. And so when we're looking inside the ticket allocator agent, Adam's going to dive in a lot more into the technical details behind it, but just giving you an overview of some of the tools that the ticket allocator agent has. So it has a series of these blue tools and pink tools. The blue ones are the tools that are more general. So you could think of these tools as tools that could be used across a bunch of use cases or different use cases. But then the pink tools are the ones that are specific to the allocation, the process of optimizing that allocation. So the first tool we have is the retrieve context tool. And what this does is allows the agent to look in its runtime environment, understand the actions it has taken and the results of those actions it has taken. So, the output of certain code, and then take action based on that. So it gives it an understanding of its runtime environment, and then it can take action through generating and executing code. And so basically this, again, really what it says on the tin in terms of the tool allows the agent to generate and execute code in that runtime environment. And then another blue tool that we have that is more general in nature, that comes with our agent building framework, is the ability for the agent to understand a data set really, really well and in depth. So this is understanding, the shape of the data, different columns, the trends within the data. So that's another tool that this agent has access to. And then a big thing we pride ourselves on at causaLens is the ability for these agents to integrate into the workflows of the business teams that they're built for. These agents don't require you to learn a new interface, learn a new tool, have a new bookmark in your browser that you have to go to because, someone said that, you need to log in. This integrates right into the tools you're used to using. And the example we're having today is in Slack. So this sends Slack messages tool, again, exactly what it does on the tin, says on the tin. This agent is actually able to send Slack results of the optimization to members of the business team. And then diving into the pink tools, the tools more related to the agent's adjusting of the optimization algorithm. First of all, the first tool it has is the ability for it to get optimization target info. So whether it's optimizing for profit or revenue or another metric, this tool allows the agent to understand that metric that it's optimizing for. Then it has getting the target penalty info. So what this means is typically in optimization use cases, what you want to do is you want to add certain constraints or penalize certain aspects of the data set based on the type of optimization or the trends that you're analyzing or understanding. And so when we're looking at the penalties that we're going to be providing today, one that we're looking at is a penalty across time, so a temporal sort of penalty, in the sense that if one vendor was selling really well 2 years ago, we don't want the agent to overvalue that. We want the agent to understand if they were selling well 2 years ago, but now they're selling really poorly, we want them to value or over-focus on the sales in recent time. So that tool allows the agent to understand and apply those penalties. And then the final tool is really, really self-explanatory, is the actual ability for the agent to do that allocation rebalancing. So to be able to reallocate those tickets across the different vendors. So I appreciate I've dived into a little bit of detail here, but what I'll do now is pass over to Adam to take us away on the journey of building this agent. Over to you.
Thank you, James. My first question is, can you guys see my screen?
The question of all webinars.
Perfect. All right, before I get into the actual agent building, I want to take some time to show you the target. What are we trying to build? So this environment here has the agent already built, and this is how it would be used, how you could create a workflow to automate the reports sent to Slack and publish it as an app that can be ingested by the business. So in this instance, I ask the agent, the custom agent, can it load my data from Databricks? And it writes the code for me, loads the data, I give it the database name, table name, loads everything for me. And actually, this works with other data providers like GCP, Snowflake, even a plain CSV file. And once the data is loaded, I finally ask the agent to do the optimization. I tell it I want to use linear programming. I give it some constraints, like, for example, I tell it what the metric to optimize is. I tell it to test on a specific day in a specific city, and I tell it to allocate a minimum of 3% of tickets to each merchant.
And Adam, just for the audience here, what we
Yeah.
can see is that you're discussing with the agent on the left, but this is the process of creating the workflow, right? So we're going to be building the agent today, but then after you've built the agent, you want to build a workflow that the agent can use or repetitively do. So whether that's on a schedule or whether that's sending messages. So just to orientate the audience is, we have these conversations on the left in a series of threads, and then they relate to the code that's been written by the agent on the right.
Exactly. Good catch. So yeah, this is the final product, and we're going to build it afterwards. But I want to visualize what it's going to look like. So me chatting on the left, asking for the optimization, it runs it for me. And just to show you how you can make it even more specific to the use case, you can add extra constraints, and then it's going to override the code and give you those results. So now it gives the results as a table, the agent, and you can see here it allocated 88% to merchant D and allocated 3% out of the other merchants. Now, yeah.
And Dara was just going to say, like, that's in line with the penalty that we just
3%.
Yeah.
Obviously, this is hard to ingest as a business. It's just numbers in a table. So my follow-up question to the agent is I ask it to plot it, all of those results for me in a bubble plot. I give it some extra requirements, like, what to put on the labels and how to annotate everything. And it creates this plot for me. And after that, I just add some code here to enable me to chat with the agent. And the next step after this is, obviously, I cannot really share this with the business, right? So what I did is I just selected all of this output that the agent wrote for us, the whole workflow, and I shared it as a dashboard. And then I asked the agent, can you share the results via Slack? And this is the URL to the dashboard. It ran this for me automatically. And then it sent in my Slack channel the data, optimized data, obviously. It sent me the visualization, and it sent me a link to the dashboard. So now anyone in the business who's relevant and who needs to see this can actually ingest it without going inside that environment. So if I click on this, this is the dashboard that I've just published, showing you this interface before. And this is a more, I would say, user-friendly way of viewing the data. So let's just let it load for a second. Maybe 5 seconds? I don't know. Here it is. So yeah, this is the raw data. It describes, what each column is so that it's like understandable. Then we have some information about the constraints that we just mentioned, but in like plain English, not in prompt. And again, you have the optimized data, you have the plot, and at the bottom you have a chat where you can, ask the agent follow-up questions. So maybe I'm seeing this from a data scientist lens, and I want to ask it, what other optimizations could it use? But then you could ask it anything. You could ask it to interpret the results for you. You could ask it for different plots. You could really ask it anything, right? It has all of this context in memory. So for example, here I asked it about other optimizations that could be used. And here you go. So we use linear programming, but these are the 8 other options. So I could even go and ask it, can you rerun the optimization using one of those techniques?
Yeah, and I guess tying this, to Darko's point that he mentioned, this is really that moment that the business stakeholder can engage with this agent and allows, the hands-off nature of the data science team and the analyst team as well.
Exactly.
Is that they can message, this can be a conversation at 1 a.m. if they want.
Exactly.
And these follow-up questions can be asked to really, really allow that business stakeholder to go deep.
Yeah, well, the data scientist can sleep.
Yes.
Perfect. So we showed you the end product. We showed you the agent already built and the workflow that it creates for us and how we can share it on Slack and as a dashboard. Now we're going to build it from scratch. So I'm going to close this and I'm going to go straight into Agent Lab. This is where we build the agents. And I'm going to click on Build from Scratch and call our agent ticket allocator. And I'm going to shove it in here. Beautiful. So at this point, we have a skeleton agent, right? It can answer questions, but it's not specific to the use case. We need to teach it how to solve this optimization problem. And the first stage for this is something called LLM guidance. So LLM guidance tells the agent, who it is, like what its role is, and it gives it a very general high-level guideline. So to do this, I would go in this file called manifest.json, and I would replace this LLM guidance here. So I'm basically telling it it's a data scientist, and it needs to solve an optimization problem. And the problem is allocating a fixed amount of a volume across vendors. And you can notice here the very vague language. This is so it can work with any use case, not just football tickets, but anything that you want to allocate across different aggregators. So that's the first part. The second part is something called the system prompt. So this is, now being more specific, we're telling the agent exactly how to execute specific tasks. And the task here being, the optimal allocation of something. So in the same way I did this, I'm going to modify the default system prompt that the skeleton has. So this is just something that you have when you create an agent from scratch. And I'm going to put my own system prompt in here. And now we're already more specific than we were before. We're telling it, again, it's a data scientist and what it needs to do. But we're telling it needs to solve this writing Python methods, right? It needs to ingest a data frame. And the data frame needs to have a location and a date. And the output should be a pandas data frame. And, this is giving a lot more instructions.
Yeah, and I guess how we like to look at it, is it fair to say like the LLM guidance is kind of the role that the agent takes on, but the system prompt is really how it should respond, how it should conduct itself.
Exactly. And now it knows what it needs to do. It doesn't know how to do it though, which is why we have something called tools. So tools are really, it's what allows the agent to have those specific capabilities that will solve the problem that we give it. So it allows it to go beyond, when you just use ChatGPT and it processes text for you. Here, it allows it to act interact with the whole environment, solve problems on its own, and then also answer user queries much more effectively. So I'm going to go ahead now and go in tools.py. So this is a file where you put all of those tools that are going to teach the agent. This file, again, it's a skeleton, so it came with 3 default tools. We really don't need them because they're for another use case, more general. So I'm going to delete them, but don't panic. I'm going to paste 4 tools that I wrote in advance that are going to be used by the agent.
Yeah.
I'm going to obviously walk you through them. Main reason is I don't want you to watch me write code for 20 minutes. There's more interesting stuff to do. So I'm going to go ahead and paste this. And again, don't panic. There are 4 tools in there, and it's going to become very clear when I walk through it. All right. The first tool is called getInfo for optimization target. Tools are defined as Python functions. And this tool here returns a string with a lot of instructions. It tells the agent in natural language, a series of if-else statements. It tells it if this is the first optimization and the user didn't specify a metric, then you should ask for it. And then it says, if it didn't specify one, maybe you can try to derive it based on common sense and logical reasoning. And if it's not the first one, then you could say repeat a metric from the past, right? And then we give it some examples of metrics. So this is quite vague, and this is done on purpose. This is called an advisory tool. So this Python function just returns a string of instructions. It's basically a very, very, very specific system prompt for that specific task. And the advantage of advisory tools is they can be flexible, right? In here, there's no mention of the method used. So in the example before with the final product, we used linear programming because that's what I asked it to. And this works for this tool because you can ask it any method really. And I want it to be vague on purpose so I can use anything.
And really, Adam, I mean, jumping in here, it's the difference between advisory and coding tools is that advisory allows that flexibility.
Exactly.
So you want it to be adaptable. I mean, this would just be a pipeline if it was just code and only code. And so this is really allowing the agent to work with instructions, but not be tied to specific pieces of code. But what Adam will jump into shortly is the benefit of where you can need a coding tool. So there is an appreciation that you do need both. You need the agent to be able to, interpret and write its own code. But then if you have a function and you want that function, you want that process to be run, and there's only one way to do it, or there's your way to do it, that's when coding tools come in.
Beautiful. This transitions very well into the next 3 tools. So I'm going to close this tool for now. There is a second tool called getInfo for penalties. It's also an advisory tool, as you can see. It just returns a string. This just tells the agent how to handle when a user requests a penalty term to be added. It gives it examples and it tells it how to apply it. And we'll show this in the future prompts. So those are the first two tools that are around the optimization. The second tool now, the third tool, sorry, is a coding tool. Now, as James mentioned, this is when you have a very specific task you want to do. So this tool is for sending the whole results to a Slack channel. And I've naturally, like, I do write code sometimes. I'm a data scientist. I've already written this code. I don't need the agent to like come up with new code. I wanted to reuse my code. So I wrap my code in a string, and the parts that I want to be dynamic, I wrap them in those curly braces. And then I tell the agent that it needs to take as input, in the prompt, it needs a URL for the dashboard. And then it's going to go and write my code and replace dynamically the URL there. So this is a coding tool, very specific. I know exactly what I want. I want it to send all the results to a Slack channel. I don't want anything else. So this is a coding tool. And same use case for the last tool, which is loading my Databricks table. So it's a tool, again, I already wrote code in one of my notebooks that loads data. I make it dynamic by changing the database name and the table name, and I wrap it in a coding tool. And that's really all the agent needs. It has the 4 tools now. So at this point, we have system prompts and we have tools, a lot of them. So we need to go ahead and connect everything together. So I'm going to go ahead and close those files to make it less confusing. And I'm going to open the main file. This is the agent. It lives in a class, and this class has many properties. I'm going to collapse them just so that it's a bit clearer to read. So you can see the ticket allocator agent has many properties. One of them is the tools property. This is where we pass all those properties. So in here, we're importing the properties that the tools that we wrote in tool.py. Those are the 3 that I deleted earlier, the 3 default ones that come with the skeleton. So I'm going to replace them with the 4 that we just wrote. And if I go in the tools property, you can see again here, those are the 3 default ones. I'm going to go ahead and delete them. And I'm going to import the 4 that we just built. And at this point now, we've given the agent the specific tools to do this. It has a default one, the one that James mentioned earlier, that allows it to understand data. Those are one of the many pre-made tools that we have, and you can reuse across all your custom agents. And we have the 4 that we just made.
And I guess just to jump in, how you want to think about this is like, this is the toolkit that the agent has.
Yeah.
So the guidance gives it the role, the system prompt gives it how it should conduct itself. But then the toolkit here is like, what can it actually call on to be able to perform a task? Correct.
And I'm going to quickly go through the other properties that are going to make this custom agent like different from other custom agents.
Sure.
So first thing is something called complex parameters. And it's simply how much the agent can view in the whole context, in the whole runtime. It can view, like text, images, numbers, data. It can be very confusing. And in our case, we know that we're just going to give it a data set. So I'm going to tell it, don't look at everything. Simply look at pandas data frames. So I've replaced variable times from none to pandas data frame.
Nice.
So now I can only see this, less likely to get confused. Other properties include the system prompt that we wrote earlier. So it's loaded in there. And there's some other ones like a list of forbidden tools. It's used for logic, like if you've run a tool once, the agent used a tool once, maybe you don't want to use it a second time, you could put it in this list. There's the default LLM configs. So this allows you to change like the model. Right now it's GPT 4.0, but you could use Claude 3.7, you could use DeepSeek, whatever is required for your use case, or if your business has a specific requirement.
Yeah. So, if we wanted to use GPT 4.5 for the vibes, we could.
Exactly.
Yeah. And again, I think it's just worth stressing the importance here that agents using different models here, they can definitely comply with all of your enterprise's needs. So this isn't about saying you can only use the off-the-shelf ones that we provide. We can sign up or connect to any of the agents, any of the LLMs that your enterprise, requires you to use.
Exactly. And this leads me to the last property, which is default max nesting level. This one it's a number that tells the agent how many times it can correct itself before it gives up to avoid like infinite loops. So obviously the more complex the task, the more big you want this number to be. So in this case, I'm going to leave it to 30.
Yeah.
And this leads nicely to the last 2 features I want to give the agent for it to be complete. So I just mentioned that it can correct itself. We have an extra tool that we have in our packages called inspect object API. And this allows the agent to see more details about all of the code that it wrote. It would understand like, the types of variables and like why it wrote this, so it would be able to debug itself more efficiently. And this is used by creating another property. So I'm just going to put this here, a property called error correction tools. So it's another set of tools just for correcting itself. And we pass in this imported tool. And the final one, that's actually my favorite. It changes everything. It's the requirement tool. So I'm going to import it and explain to you what this does. This tool allows the agent to ask follow-up questions. So if you recall, the Slack coding tool requires an app URL to like replace what I wrote in my own code. If you don't give it, it's going to be like, whoa, I'm missing something here. Let me ask a follow-up question. This is what this tool allows you to do. And for this, you're basically going to add it to the list of tools that we already have here. So we have the default one, we have the 4 custom tools that we wrote, and I'll go ahead and add a 6th one. And what I'm at it, I also have some examples that I've written in advance. So those, by examples, I mean, it's the examples of follow-up questions. So I'm going to go ahead and put this in a separate file called requirements.py, and there's just example follow-up questions. Like if it asks for a constraint, then you should check for this. If it asks for a metric to optimize, ask for this. And I'm just going to go ahead and import this in the main agent file. And that's not the one, sorry. There we go. And this is going to be used here. We're passing it inside the requirements tool. So at this point, I believe the agent is done, as in it's fully written. It should be functioning. Fingers crossed. And we're going to go ahead and test it, because you can't just like give this to your business without having tested it, obviously. So usually you would test it in here. You would write your prompt, chat with it, you get an output, and you would see if you're happy with it. But if you want this to be consistent, you can use an evaluation pipeline. And I've created an evaluation pipeline in advance. And the way it works is, so first let me create a new pipeline. It's going to be basically a series of prompts. And for each prompt, there'd be an expected text output in the chat and an expected code output in the actual runtime. So I'm going to go ahead and add one. So let's say this is my prompt. Can you load my data set? I already know, because I've run it many times, that this is the output I want. I want it to tell me that. And I also know the code that it should write. So I'm going to go ahead and enter this here. So that this is one step of the pipeline. Prompt, expected text, expected output. To make the pipeline a bit more interesting than just one prompt, I'm going to add a second one, which is the optimization prompt that I showed in the example earlier, the linear programming one. So I'm going to put the prompt in here. I'm going to put the expected text that I wanted to like reply in the chat. And I'm also going to write the expected code that it should write if it does it correctly. So there you go. I'm going to add all of this. Now the pipeline has 2 items. And what is the point of the pipeline? Like I said, it's to test that it's, consistent.
And I guess jumping in, like you can think of this as like the exam that the agent has to run before it can be let out in the wild. It's like the performance review of this AI data scientist.
Exactly. And exams have test scores. So this is what we're going to do now. We have metrics that we have implemented. We have a few different ones. Cosine similarity is for the semantic meaning, as in like the actual like meaning behind words. If they're not the exact same words but have the same meaning, that's correct. String contains is more strict. It's to make sure that there's exactly the same wording in both the expected and the actual output. And LLM as a judge is going to use a separate LLM to test the correctness of the output. So this is a much more robust one, but it takes longer. It takes more compute as well.
Because it's basically like 2 LLMs talking to each other, right?
Literally.
Judging each other's,
Exactly. Hence LLM as a judge. So in this instance, I am going to test the code with cosine similarity, and I'll test the text with string contains. The reason I don't do LLM as a judge, which I usually do, is because it takes quite long to run, and we don't want this webinar to last into the night. So I'm going to go ahead and update this, and I'm going to run the pipeline. When I run the pipeline, it's going to start running the different prompts that we wrote down there, and it's going to check if the output matches the expected. And it's going to plot them here. It's going to plot the 2 metrics that we chose, like the test scores, and we're going to be able to measure them. They're scored out of 100. And the point of this is, right, we coded everything one shot here, but technically you're going to iterate a few times. And every time you iterate, you're going to want to make sure that it's consistent, or very, like, ideally getting better. So you will have many prompts here, and they're going to be plotted, and ideally they will go upwards. So in this instance, we're not going to iterate to the agent. We're going to assume that we're happy with the results. We got 69% on the text. The other one didn't run because the data was not important. So I need to like go back and change this later. But let's assume we're happy with the results. Accuracy is going up. We're ready to share it now with our organization. So we can give it some metadata. We could give it a description. We're going to give it a version so that we can, every time we iterate and we're happy with new results, especially if the pipeline runs correctly and we get good results, we can up the version. We can give it a color. I'm just going to give it red. And then we can share it with, our business. I'm going to hit publish. Now this agent is completed, and we can replicate technically the workflow that we showed earlier, where we ask it to load our data. It's going to use the tool of the loading the data, and we can ask all of the optimizations. We can publish in a notebook. Sorry, not in a notebook. We can publish as a separate app, and we can share this on Slack. So if I go back to this example here, now hopefully everything here should make much more sense, right? So I'm not going to actually run through the prompts, because I just run the prompts and we'll get the same output.
Yep.
That sounds very exciting. I would rather get to the Q&A faster. So I'm going to reiterate what happened earlier so that we can actually see the value. So if you recall, we create a tool that loads data. We ask it to load data from Databricks specifically. If I had written from CSV, it would have done something different. Here, the agent knows to use the tool that we created earlier. So I give it the database name, I give it the table name, and it loads it in. And you can see it loads it in perfectly here. Then the second step is to actually create the workflow, create the optimization. Ask the agent to run linear programming to find the optimum split, the optimal allocation of tickets. The metric is likelihood of selling times total potential revenue. This is in the data, and this is my custom metric. Those two things together are going to be optimized using linear programming. And I give it some extra constraints, like the no merchant should receive less than 2%, do it on a specific day in a specific town. And once I run this, so this is not the actual output, because in this case, I asked a follow-up question. I asked it to add a penalty factor. And this works because we added the tool that allows the agent to understand how penalty factors work. So here it's going to recalculate a new optimal allocation based on the penalty. So if I go here it says optimal allocation. And you can see 88% to merchant D and 3% to all of the others. And like before, it's not very nice to look at. We'd rather have a plot. And I think it's quite interesting because if you recall, we didn't write a tool to create the plot. This is something that LLMs can do generally. So they know some stuff generally. We gave it tools for specific tasks, but for plotting, we can just ask it directly. So here I ask it to create a bubble plot for me, and it does that. And finally, this is just code so that we can chat with it. Finally, the last thing is the Slack code. So if I go at the bottom, all we asked is, can we share the results via Slack? And then we gave it the app URL, because if you recall, we manually selected all of the output and we clicked on publish. And this created this dashboard that we saw earlier here.
Yeah.
Yeah.
And if we go back there, I mean, that's the example of where a code tool is really valuable, right?
Yeah, exactly. Good. Yeah, they did exactly the way I wanted it. It used the right variables. This is exactly what I wanted. And then it sent everything to Slack, same as here, and with the link to the app, which opened this here. And that is pretty much it. You could ask more questions to the agent. Like for me, the next logical step would be to run this as a pipeline. Every time the Databricks connection updates, you would want this to run, like, whenever there's an update. It triggers it, rerun the whole code, get the output. And yeah, that's pretty much it.
Cool. Thank you very much, Adam. I think we'll go to some Q&A for now. Darko, do you want to come back in?
Oh, guys, that was awesome. Yeah. And I think the other thing, you guys probably covered it, but if something changes, like a new requirement emerges, or we no longer want to give more than 20% to to a merchant or something like that, we don't need to go to the beginning and kind of rebuild everything. This is a kind of the big difference between the old platforms where you had like a model in model ops, in ML ops, like in hard coded. Here we can be a lot more flexible. We can, we don't need to go back to a data scientist if we want to change some things inside the AI. So that's kind of, I'm not sure if you guys covered that, but for me that was you did, yeah. Great.
No,
Excellent.
You have to reiterate.
It's just kind of an important thing, because I think it's there's a lot of maintenance that goes into AI systems, and I think we can kind of automate a lot of that now.
Yeah, and as Darko mentioned, like that's really characterized by those advisory tools, right?
Exactly.
We're advising the agent on what to do. We're not giving it strict instructions. It's not just a pipeline. It can do, all types of optimizations.
Exactly, and it works so well with the app, like the chat inside the dashboard, because you can ask the follow-up questions there. You can change the constraints, you can change everything in there without going to the data scientist.
Wow, cool. So jumping into some questions, we've got a few questions here that I'll read through. First of all, I see a few questions on, are we going to get a replay of this webinar? Yes, we will. So you will be able to access this. But I think a really interesting one to jump into is a question around, or I'll just read from the questions. It feels like I need some programming knowledge and some knowledge of basic data science techniques to build an agent like this. Is that a correct understanding?
So we have 3 steps in our master plan. The first step is empowering the human data scientists to have an army of juniors, right? So that's kind of our first step, and we want to turn every human data scientist into 100, and that's what you guys saw today. And so for that you do need coding and things like that. So we are assuming you're a data scientist and you'll want to become 100x, right? That's what we showed today. Now very soon we'll be able to unveil some tools around step 2 of our master plan, which is around semi-autonomous agents. Those semi-autonomous agents do not require building a custom agent. So once we reach step 2 of our master plan, what you saw today will be less relevant. It will enable, in step 2, will enable almost anyone to say, here is my objective, here's my data, go ahead and build out things for me. And I had obviously an ability to play with this technology already. And I asked it to take my Aura data and my 8 sleep data and to tell me what is the causal impact of 8 sleep on my sleep score. And I went away, had dinner, played with my toddler, did all of that stuff, and I came back and it had beautiful model and insight around whether 8 sleep impacts my sleep score. So that's when we get to that step and we share it with our customers, you'll be able to use AI agents for data science without programming knowledge. But for now, if you're a data scientist and you want to be 100 and you want agents to do the groundwork, this is the way to do it.
Yeah, and I think the design consideration behind that was really about flexibility and providing data scientists room to breathe and room to work. When you have these no-code, low-code environments, what we often find is that they're suffocating in terms of like allowing tools to talk to each other and allowing you to really build a robust solution. So we've tried to keep it obviously assistive. You've seen that we provide in our framework, a really great framework and structure for building an agent, but we provide a bunch of tools for you to get started as well.
Yeah,
correct. Cool. Another question we've got here is, I guess tying in, Darko, to your point, is have customers actively adopted using these agents, and any examples that you've got?
Yeah, so if you guys tune in on the 1st of April at our San Francisco conference, you'll be able to hear it firsthand.
Yeah, cool.
So yes, a lot of them, yeah, and some of the most impressive logos on the planet.
Yeah, and another question we have here is, it's great to see agents for football ticketing. Thank you. Hopefully they're valuable if you want to copy all the code and allocate your tickets. But I guess there was a question here on how many agents do you need to create in a typical use case, and can you size this before starting? I guess you're happy for me to take this one. Yeah, so agents, I mean, it really depends on the depth of the use case, right? We've got a lot of project going on with customers right now, and depending on how deep and how deep or wide this use case is. It could be, you know, one of our planning agents, which helps you orchestrate and create plans and collaborate with multiple agents. You know, if it's a more in-depth multi-step use case, that could be more appropriate. But for example, we have a very clear task here, a very clear goal. And so we can have an agent use a series of tools to achieve that objective. So it really does depend on the use case, how you choose to scope it. But obviously, got a great team of data scientists at your disposal when working with causaLens. So yeah, that scoping is very much a part of the plan. But yes, one or many is the answer. Great. Another question here just around, let's see, which one?
The data one was interesting, maybe. What if you don't have the data? I noticed somewhere.
Oh, yeah.
I think impressive have and
Oh,
you
yeah.
can give a sense of the work necessary.
Yes. Yeah.
So maybe just to read the question, I guess. I don't want to read it. I'll answer it.
Yeah.
Cool. Yeah, I can read it.
Oh, yeah,
Yeah, so it says impressive. However, can you give a sense of all the work necessary before you can start building an agent when you onboard a new customer? The main challenge remains data onboarding and quality. I'm curious to get a realistic sense of the pre-work.
Yeah, so the good news is if you tune in again on the 1st of April, we will show you a very impressive agentic system for manipulating, cleaning, preparing data for AI. And you're right, 80% of the work of a data scientist is cleaning data. And it is not fun work. No one likes it. You know, Adam, you know,
No.
hates
I can
it.
confirm. I've written my own agents for
Now,
this.
wouldn't it be wonderful if you had, you know, 100 agents helping you sort out the data? So yeah, tune in the 1st of April in San Francisco, and you'll see it firsthand. How you no longer have to spend 80% of your day miserable, you know, cleaning data.
Cool. Yes, and so we have a bunch of questions coming in here, but what we'll do is we'll follow up with answers to these questions. But what I'll do here is just wrap up, say a massive thank you. First of all, thank you to everyone tuning in, spending the time with us, building this agent. Hope you got some value from it. And yeah, thank you very much to Darko as well.
You guys.
Thank you, guys.
Thank you.